Welcome to the Bodhi Academy. My name is Amisha Halaso, and in today's video, we will start with a new chapter of Class 8, Chapter 8, Force and Pressure. So now, when we talk about force, okay, say now there is a field, a football ground, say, and there are two teams that are playing on the ground. So now consider there are two players over there, and that's the ball. Now say no one is making an effort to apply any kind of force or to strike the ball. Will the ball move from its place? No. So there has to be some kind of strike, kick or push that has to be made so that the ball can move from one person to another. Or even if somebody wants to hit a goal, in that case also you need to apply some kind of force that will make the ball move. So that kind of force and pressure we are going to study in this chapter. We'll see what are the different types of forces, then what are the impacts of these forces on the object that you're applying it on. Then further also we'll see about pressure and some more stuff in this chapter. So now to begin with, in class 7th, you have learned how objects move. So do you recall how we can decide whether an object is moving faster than the other? So now say you see there's a race happening and there are two uh, people running in that race. Now say how on what basis do you decide the one out of two who is running faster? So obviously that is by visuals. The one who will be running ahead, we will say that that person is moving or running faster. So what does the distance moved by an object in unit time indicate? You also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. It is also possible that a ball may slow down and also change its direction. Have you ever wondered what makes an object slow down or go faster or change its direction of motion? So have you ever thought, now see there's a ball on the field. See you kicked it only once. Okay, after some time, in the initial time it will move very fast, but after some time gradually the speed will decrease. So now on what basis or how do we know that the a ball is going to move faster or slow, or if it is going to change its direction of motion? Let us recall some of our everyday experiences. So what do you do to make a football move? So you strike it, you hit it, or you kick it, right? So what do you do to make a moving ball move faster? So now if there's a ball moving, then what you will do to make it move faster? Yeah, you will give another hit to it or you will kick it again so it moves a little faster. How does a goalkeeper stop a ball? It will stop it with its hands. So it will block the incoming ball. The hockey player changes the direction of a moving ball with a flick of a stick. Now say in ball and when it is a football, it is a larger ball as compared to a hockey ball. Hockey balls are very small. So in that case, that hockey ball is just controlled by that stick, hockey stick that is there. And just with the help of that hockey stick, you can even change the direction of that ball. How do fielders stop a ball hit by a batsman? They stop it with their hands. They apply some force to stop the ball. So in all these situations, the ball is either made to move faster or slower by its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown or flicked. What is a force? So now when we are kicking a ball, we are pushing something, we are pulling something or we are throwing something, that means we are applying some kind of force. So now what is exactly this force? Force, a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Now these picking, opening, shutting, these all things we do in everyday life. We pick something that is fallen, we open a door, we shut a door, we kick something on the road, we hit something, we lift many we lift our bags every day. Then there's pushing, pulling. All these tasks or all these activities are done on daily basis. Now each of these actions usually result in some kind of change in state of object, of motion of an object. Say now you're picking something, so you're changing that object's place. It was firstly see, now say there's a pen fallen down, you pick it and you keep it somewhere else, so you have changed the position of that pen, right? Then opening, you open the door, you're changing the state of the door. So your first it was closed, then you opened it, there is some kind of change that is happening. Can these terms be replaced with one or more terms? Let us find out. Now say, okay, see there's an activity given here. So in this activity what you have to do is you have to uh, there are different descriptions of situations. You have to say if you can, what are the things you can do, what are the actions you can do, like pushing, pulling, picking, hitting, lifting, lowering, flying, kicking, throwing, shutting or flicking. You can place any of these words in this columns given below. So now see, one is solved here. Moving a book placed on a table. So if there's a book placed, so what I will do is I will push it, okay? Or if I want the book near me, I will pull the book. Or if it is fallen down, you will lift it, right? Then opening or shutting a door. So that will be what? You will either push it or you will pull it. So pushing and pulling. Then drawing. Okay, there is another column here. Actions can be grouped as push or pull. So here we can say that it is a push, right? So you can say we can have push and pull. So in this case also we can have push and pull here. Both the things can happen. Drawing a bucket of water from a well, that will be pulling or lifting, because you will be lifting it up. You won't push it down. So you will lift it up. So it will be pulling or lifting, and here you will mark pulling. Then a football player taking a penalty kick. So he will be pushing, or we can say he was kicking the ball. So there will be some kind of push happening to the ball and it will be kicking. Then a cricket ball hit by a batsman. So that will be what? Flying, because the ball will go flying. Then we can even say it is hitting. So in that case, we can again consider it as a push, because the ball is being pushed by the bat. Moving a loaded cart. So in that case, you can either see, you can either push it if you want to, if you want it towards yourself, or you pull it. You push it. Okay. Pulling, if you want it towards yourself, you pull it. If you don't want it towards yourself, you have to push it away, then you push it down. So then here both the things can happen, push and pull. Then opening a drawer, so you will pull it, and here also will get as a pull. So do you notice that each of these actions can be grouped as a push or a pull or both? Can we infer from this that to move an object, it has to be pushed or pulled? So now to move any objects, what we are saying is that you either have to push it or you have to pull it. So either of the things will make the object move. So in science, a push or a pull on an object is called as a force. So when you push or you pull something, you push or you pull an object, then it is termed as force. Thus, we can say that the motion imparted to objects was due to action of force. So now, if there was any motion in the object, we can say that it was due to the force that was imparted or the force that was applied onto that object. When do a force come into play? Let us find out. Now, forces are due to an interaction. Now, say when we said about the football match, so there was the ball and there was the player that was playing. So in that case, what was happening? There were two people. There was some kind of interaction between the player and the ball. If there was no interaction, say both are standing over there, there's no movement, there's no interaction happening. Will the ball move or will the player move? No, none of them are moving, so there is no motion of the object also happening. So there has to be some kind of interaction between the player and the ball. That is, the player has to kick the ball so that the object goes into some state of motion. So suppose a man is standing behind a stationary car. Will the car move due to his presence? Suppose the man now begins to push the car. That is, he applies a force on it. The car may begin to move in the direction of the applied force. Now say, what they are saying here is that, say this man is standing here and there's this car. Okay, firstly, now they are just standing. Okay, the man is right there behind the car and the car is there. Nothing is happening, just the presence of the man is there. Will the presence of that man make the car move? No, obviously not, because there is no kind of interaction that is happening between the car and the person. Now say the person decides to push the car in the opposite direction, right? So he pushes the car. In that case, the car may move. Why? Because there is some kind of interaction. So the man is applying some force to the car, or there is some interaction between the car and the man that is making the car move. So note that the man has to push the car to make it move. Then in figure 8.3 shows three situations that may be similar to you. Can you decide who is pulling and who is pushing in these cases? So now see here. In this case, who is pushing whom? So here, what we can say is that both are pushing each other. So that's why you cannot see there is some kind of, there will be no movement happening in such cases. When the force is equal from both directions, there is no movement. And also in such situations, because the force is being applied in both directions, you cannot tell who is pushing whom. In the case of the car and the man, the car was stationary. It was at its place. It was not applying any force against the man. Only the man was applying some kind of force against the car to make it move. But here in this case, these two girls, they are applying equal force towards each other. So that's why it is difficult to tell that who is pushing whom, because both of them are pushing each other. It is not one person. See, in this case also, both are pulling each other. We cannot decide who is pulling whom. Both are pulling each other. So both the girls appear to push each other, while the pair of girls in 8.3b are trying to pull each other. Similarly, the cow and the men appear to pull each other. Here also the cow is trying to pull the man and the man is trying to pull the cow. Both are applying some kind of force to pull each other. The girls in the two situations shown here are applying forces on each other. It is also true for the man and the cow. Yes. So from these examples, we can infer that at least two objects must interact for a force to come into play. That is what we are trying to say. For some kind of force to come into play, the two objects that are there, they should interact with each other. Without any interaction, no force will be generated. Thus, an interaction of an object with another object results in the force between the two objects. Now, exploring the forces. Let us try to learn more about forces. Now see. Now say, what they are saying is there's this heavy box, okay? And there's this only one fellow in yellow shirt in the first scenario. So he's trying to push the box. Will he be able to move the box? No. Because firstly, let's say it is a wooden box and it is very heavy. So he won't be able to push it alone. Now say he gets some help. He calls his friend to help him push the box. So in that case, the box may move at some extent. Now, in the second scenario, what happens is both of them, the guy in yellow, say he's on one side and the guy in green is on the other side. Both of them are applying force from opposite direction. Will the box move? No. So there is no movement of object that will happen in this case. So now say when we have the game of tug of war, what happens is the one who pulls more is going to win, because you have to pull the opponent's team. But in some cases what happens is there is no movement at all happening. In that case, what we'll say that the force that is being applied from both the sides is equal, due to which there is no movement happening. There is, the net force becomes zero over there. Say now on one side their force is say around 4, okay, 4, and the other side their force is only 2. So what will happen? The force is more on the side of the 4 people, and other side there is only a force of 2 people. So they will easily pull them, right? But now say there are four people each on each side. Now in that case, what will happen? There is equal force on both the sides. So their net force will be 0. So now what do these examples suggest about the nature of force? Force applied on an object in the same direction add to one another. So now say I am in that first case where they were trying to move the box, and then now say there was a force of only one person initially. That was not enough to move the box. When the other person came, their forces doubled because there was another person's force that was adding on. In that case, the box was able to be moved. Now recall what happened when you and your friend pushed a heavy box in the same direction, so they were able to move it. If the two forces act in opposite direction of an object, the net force acting on it is the difference between the two forces. So now when I said the game of tug of war, they were applying forces on the opposite direction. One has to push, one has to pull, right? So in that case, what happens? That is the difference between the two forces that becomes the net force that acts on that object. Now, what did you observe in the activity 8.2 when both of you were pushing the heavy box from opposite direction? The box was not moving because I am also applying force in this direction, and equally the person on the opposite is also applying force in the other direction. So the box was not moving. Recall that in the tug of war, when two teams pull equally hard, the rope do not move in any direction. In that case, what we say, the force applied on both sides is equal. So we learned that force could be larger or smaller than the other or equal to each other. The strength of a force is usually expressed by its magnitude. So what we are saying is that now force can be larger or smaller than the other. One may have a higher force, the other one may have a lower force. Also, it can be equal. The strength of the force that is usually given by magnitude. We have also specified, we have to also specify the direction in which a force acts. Also, if the direction or the magnitude of the applied force changes, its effect also changes. Now, a force can change the state of motion. Let us find out what happens when a force acts on an object. So, for example, while taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest. So its speed was 0. So now suppose there is a penalty shot happening over there, and initially what happens? The ball is at rest. There is no movement of the ball that is happening. So but when the player tries to hit the ball or kicks the ball, there is some kind of speed that is generated. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. So, the force that was applied by the player to make a shot, similar force will be applied by the goalkeeper to stop that ball. So, the force applied by him can stop or deflect the ball, saving a goal being scored. So in that case, what many times what we have seen, sometimes the goalkeeper catches the ball right into his hand. Sometimes he just pushes the ball away. That changes the direction of the ball. The ball doesn't hit the goal, but it goes somewhere out. If the goalkeeper succeeds in stopping the ball, its speed decreases to 0. These observations suggest that a force applied on an object may change its speed. If the force applied on the object is in direction of its motion, the speed of the object increases. If the force is applied in the direction opposite to the change of motion, then it results in a decrease in the speed of an object. So now what happens? Now say there's a moving ball, okay? Its speed is gradually decreasing. Now you again kick the ball in the same direction, okay? So now what has happened? Its speed has increased. Now when we were talking about the goalkeeper, what happened was when the player kicked the ball, the speed of the ball was very fast. If it had to hit the goal also, it would hit with the same force. But then what happened? The goalkeeper stopped the ball. In that case, the speed of the ball decreased because a force in the opposite direction to that object was applied. Paheli is curious to know whether application of force can only change the speed of an object. Now say, okay, so now say you have a ball and you're hitting it. Okay, you're hitting it and you're catching it, hitting it, catching it. Now say like there's a bouncing ball. What you do is you bring a ruler close to it. Okay, you get a scale close to it. Now what will happen? The ball will go in this direction and it will get deflected. Now what has happened here? The direction of the ball has shifted. Okay, first it was in one direction. The moment you got the scale close to it and the ball struck the surface of the scale, its direction changed. So what we are trying to say is not only the speed of an object changes, but also sometimes the direction of an object also changes. Let us consider some more examples. In a game of volleyball, players often push the moving ball to their teammates to make a winning move. Sometimes the ball is returned to the other side of the court by pushing or smashing it. So what they do, they pass the ball from one person to another in their team itself, on their side itself, and then sometimes to make a score, they smash or they hit it on the push it to the other side. In cricket, the batsman plays his or her shot by applying a force on the ball with the bat. So a force from the bat is applied. So in that case, what happens? Say now initially the ball is coming straight. Okay, the bowler throws the ball straight right at the batsman. The batsman hits the ball and that changes the direction. The moment the ball touches the bat, the direction of the ball changes and so does the speed of the ball. Is there any change in the direction of the ball in these cases? Yes. In all these examples, the speed and the direction of the moving ball change due to the application of force. A change in either the speed of an object or its direction of motion or both is described as a change in state of motion. So either if the speed of the object changes or the direction of the object changes, then it is described as there is some change in state of motion. Thus a force may bring a change in state of motion of an object. Does it mean that the application of force would result in change in the state of motion of an object? Yes. It is common experience that many times application of force does not result in change in state of motion. Say now you are pushing a wall, okay? Now in that case what happens? No matter how much force you apply, your force won't be enough to make that wall move. So in some cases, change in state of motion won't occur. Then, now a force can change the shape of an object. So now here there is an activity. So what they are saying is we have to mention if there is a change in state of motion or change in the shape. Now say a lump of dough on the plate. Now you are pressing it down with your hands. You are kneading it, right? So you are applying some force beneath. So what happens is there a change of motion, state of motion? No. The dough is right there only. But what happens is there is a change in shape. The dough compresses. It goes inside, right? Then a spring fixed to a seat of a bicycle by sitting on the seat. Now say there is a spring over there and you decide to sit on it. Is there a change in state of motion? Again, no. But is there a change in shape? Yes. What has happened? The spring was first opened up, then it was compressed. Next, a rubber band suspended from a hook nail fixed on a wall. So in that case, you're say pulling it. In that case, again, there is no change in state of motion, but its shape is changing. It is elongated. Now, what do you conclude from the observations noted in table 8.2? What happens when you apply an inflated when you apply a force on an inflated balloon by pressing it between your palms. What happens to the shape of ball of dough when it is rolled into a chapati? So it becomes flat. Initially it was in the form of like a dough or a ball like thing. Then when you roll it into a chapati, it becomes completely flat. What happens when you press a rubber ball placed on a table? It will change its shape. So in all these examples, you saw that the application of force on an object may change its shape. Having performed all of these activities, you may have realized that force may make an object move from rest, may change the speed of an object, may change the direction of motion of an object, may bring about a change in the shape of an object, and it may also cause some or all of these above effects. So while a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Thus, an object cannot move by itself, it cannot change speed by itself, it cannot change direction by itself, and its shape cannot be changed by itself. So all of these changes, change in speed, change in shape, change in position, change in motion, all of these things won't happen until and unless some kind of force is being applied. Okay, so in today's part of this chapter, we learned firstly what is force. We said that any kind of push or pull that happens is defined as a force. Then we learned that force has to happen. For force to occur, there has to be some kind of interaction between two people. If there is no interaction, then there is no force that will be acting on anything. Then exploring forces, we said that we talked about opposite, equal and opposite forces, and we talked about what happens when the force is applied on the same direction. So that time what happens, the force adds up, but if you apply it on the opposite directions, then the net force becomes zero. Then we saw a force can change the state of motion, that is, it can make an object move, also it can change its direction. And lastly, we saw force can change the shape of an object. That is, if you apply some pressure on some things, there is some kind of deformation that will happen in that objects. So thank you so much for watching today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.